In this video we're going to take a look at some of the rules in geometry, and we're going to start with ones that we would have seen back in primary school. So the first one I'm going to start with here is a straight line, and hopefully what you can remember from primary school is that in a straight line, if I was to start here and go around this way to make an angle, so if I start here and I rotate all the way around until I get to the other side of the line, that rotation would be 180 degrees. So whenever you have a straight line, you have 180 degrees of a rotation. The next one I have here is this cross shape, and I like to think of it as the scissor theorem. And why I call it the scissor theorem is because it makes this X shape like a scissors, but it also acts and describes how a scissor works. So we have an angle here, and I'm going to just say that that angle is 70 degrees. What this rule tells us is if you get this X shape like this, the angles opposite to each other are always equal in measure. So that one's also 70. It works the same this way. If I have an angle here and I have, say, 110, then this one has to be 110. Okay, so vertically opposite angles, or just angles that are directly across from each other and make this shape, they're going to be equal in measure. The next shape I'm going to look at then is this triangle. And if you have a triangle, you should hopefully remember from primary school that this yellow angle and this blue angle over here and this green angle down here, that all of those angles are equal to 180 degrees. So the yellow plus blue plus green is equal to 180. And these are all theorems, they're facts. They're given to us and we're allowed to use them. You do have to learn how to prove them eventually, but for now, we just need to remember them as facts. Okay. The next one I have here is the X shape again. And I want to talk about the X shape again because there's also something else we could talk about. If I start there and I come right the way around until I reach this point again, I've done a full circle. And hopefully you'll remember that a full circle is 360 degrees. So 360 degrees in a full circle. And the last shape that I have is a triangle again. And it's got these two lines in it. And if it's got those two lines, they're marked as special lines because they are special. They're actually equal to each other. And if they're equal to each other, then what we also happen to know is that their angles are equal to each other. So this angle here will have the exact same measurement as this angle over here. So if the sides are equal to each other, then the angles are equal to each other as well. So all of these mathematical facts, these geometric facts, they're called theorems, but what we can do is we can use them to solve problems. And one of the problems that we might be asked to look at is this guy here. So it's 76 degrees, X, and 243. So how am I going to solve that? What I would encourage you to do with these, while they are nice and easy, and you know and can see what the answer can be, I would practice using the algebra skills, because as I said earlier, you are expected eventually to be able to prove those theorems, to prove these facts that they are true, and you won't be able to do that without really good algebra skills. So I would suggest that at this point, when you're learning how to do geometry and you're practicing your algebra, that you do it in full. And what I mean by that is I'm going to take that this is a full circle. If I went the whole way around from this point and I went the whole way around here, that would give me 360 degrees. But what we also notice is that that 360 degrees is actually broken up into 76 and X and 243. And when I add those three things together, I'm going to get that it's equal to 360 degrees. So what do I do now? Well, I'm going to apply my algebra skills. So I'm going to add my like terms together. So anything that's an x gets added together, and anything that's a number gets added together. And when I do that, I just have x on its own, and then I have 76 plus 243, that's 319 degrees. They're all degrees. And it's equal to 360. So I want to find out what x is on its own, but I don't have x on its own at the moment. I have x plus 319. And if I want to get x on its own, I'm going to subtract 319 from both sides. And what that leaves me with is x is equal to, that goes to 0, and I get 41 degrees. So there's that one. The next one then that we'll take a look at has got to do with isosceles triangles. And I know it's an isosceles triangle because of those two lines, right? Those two lines tell us that those two sides are equal. And if you go back to the beginning of the video and think back to the beginning of the video, I did tell us that the angles were also equal. So if you've got those two sides that are equal in measure, we also have that this angle is equal to it. So you can just mark that in. You don't need to do algebra on it. But you would need to explain why. And why you're choosing that is because the vertically opposite, or well, the opposite angles are equal in measure in this case, right? Because it's isosceles. Now, I'm looking at the bigger picture, and the bigger picture is a triangle. And I have this triangle, and what I know about a triangle is that this angle, and this angle all sum up to 180. That's just a fact. So x plus 71 plus 71 is equal to 180. I then have x plus, we add our like terms together, so adding 71 together, I'm going to get 142, and it's equal to 180. And the reason why it's equal to 180 again is because the shape is a triangle, and we learnt earlier on that all of the angles in a triangle are going to add up to 180. So that's how you're deciding each time what it's going to be equal to. Is it a straight line I'm working with? Is it a triangle? Is it a square? You know, you might have different shapes, quadrilaterals and so on. But in this case we have that it's equal to 180 because it's a triangle. Now what I'm going to do is I'm going to get x on its own, and to get x on its own I have to take away 142 from both sides. So what happens is that on this side I'm just left with x. These two are going to eliminate each other, and I'm going to have 180 minus 142, and I get 38 degrees. So that x up there was 38 degrees. And the last example, it's another triangle. It's not isosceles, but we are given some other information. And what I would be looking at here then is this guy. I might think about what this angle here represents. Well, if we think back to what we talked about, the very first one, if I swing that right the way around, I've made a 180 degree rotation. But when I do that rotation here, up as far as here, I've already done 113 degrees of that rotation. So how am I going to find what's left over in here? Well, if I have 180 and I've already accounted for 113, if I take that away from 180, I'm going to get 67. That gives me that angle in there. And now we're back to a triangle. If I've got this triangle here, I have 180 degrees inside that triangle. So I know, because it's a triangle, that 67 plus x plus 85, that must equal to 180. And it's equal to 180 because it's a triangle. So if I add these up, 67 and 85, I'm going to have x plus 152, And that 152 is just coming from 67 plus 85. And when I do that, then it's equal to 180. And I'm going to take away from 180, take away my 152, and I'm going to get x is equal to 28. And that's it. So it's just a few rules that we have to learn at the very beginning. And these are those rules again. So you have to know that in a straight line, it's 180 degrees. You have to know that vertically opposite angles are equal in measure. It's also true for the ones that are directly across from each other when they make that scissored shape. We also know that all of the angles in a triangle add up to 180. If you can draw a full circle, you've got 360. And we learnt about isosceles triangles, where the two sides are equal, and if the two sides are equal, then the two angles are equal. So all of those rules, those facts, they are called theorems, and that's what you're applying in these questions.